Hi, I'm Eric Shanks. I'm a Senior Technical Marketing Architect with VMware. And today I wanted to talk to you about modernizing vSphere applications on AWS with VMware Tanzu, specifically VMware Cloud on AWS. So first, I want to talk a little bit about what VMware Cloud on AWS actually is. First off, it's a jointly engineered solution. It's the same vSphere that you've been used to running on premises or in your data centers, now on AWS bare metal infrastructure. So we take the best private cloud in the world with the biggest public cloud in the world. We've kind of meshed those two together. But it's not individual companies working alone on the other company's software. It's jointly engineered. The two companies came together to build this. Delivered and operated by VMware, so you get one bill, you got one support vector to go through to get help. But it provides on-demand capacity and flexible consumption, right? You've still got vSphere, but now underneath of that is AWS's scalable infrastructure. We can use AWS's global footprint, so now your data centers can be closer to home if you need to. But also, one of the things I really wanted to mention is the new services that are now out for VMware Cloud and AWS, specifically Tanzu services. And we're going to talk about those today in the session. But this was just announced at VMworld this year. We're really excited about it. Another thing that we're going to be doing with modern apps, specifically, is direct access to AWS services. So now your vSphere environment can now also use native AWS services as part of their applications. And now that Tanzu is available on VMware Cloud and AWS, you also have fully managed Kubernetes capabilities. So VMware Cloud and AWS is not something new. This has been around for a little while. First introduced in October of 2016, it was announced. And then a year later in 2017, it came to fruition and it was available. We've been improving that ever since. Every year we get a little bit better. And then recently, we have also announced VMware Cloud on AWS Outposts. Since it was so successful, now you can run VMware Cloud on AWS in your data center on Outposts. Now, typical use cases for VMware Cloud on AWS have been disaster recovery. Makes a lot of sense. So I've got a vSphere environment on-prem. I can have a vSphere environment in the cloud, specifically anywhere AWS has their global footprint. And now I've got a DR site and I can decide where that DR site is. I can also decide, I don't need to pay for the brick and mortar for my DR site all the time. I can expand my DR site as I need to. That's a very common use case for VMware Cloud and AWS. Another one might be data center extension, where maybe your on-prem data center needs some more capacity, and you are in a procurement cycle where you're not able to actually get that extra capacity. You could scale it up with VMware Cloud and AWS. You're still running vSphere. You've just got cloud infrastructure. Cloud migration is another one. So in some cases, it's time-consuming and tedious to either re-architect your applications or to convert your applications from a vSphere VM to, say, an EC2 instance. Cloud migration is one of those things we can actually live migrate or vMotion our workloads from on-prem into the cloud and help us to do things like evacuate a data center or something if we've got a disaster coming, maybe a hurricane or something. Or in some cases, maybe we're just done paying for our on-premises data center and we're trying to evacuate it that way. But what we're really going to focus on the rest of the presentation is the next generation apps. And I'm going to talk about Tanzu services and how we might modernize apps with VMware Cloud on AWS. So here I've got a IT administrator, and they're really excited. This is a pinnacle moment in their company's IT infrastructure. They've finally taken one of their applications and they modernized it, right? It's no longer that giant monolith. They've broken it down into a distributed monolith or microservices, and they're really ecstatic about how they got this application up and running, and it's their first modern app. But the thing that drives the IT manager crazy is, what are we going to do with all the rest of our applications? Like that first application getting into the cloud and modernizing it was great. We got a whole fleet of applications that we're still managing on-prem. What do we do with those? And this is really the crux of the issue, because those things take time. They take time and money to actually modernize these applications. So here's some of the challenges about implementing a hybrid cloud strategy and modernizing our apps. It was noted by Gartner that through 2022, there's insufficient cloud IaaS skills, and they're going to delay migration efforts to the cloud and modernizing your applications. If you can't actually go in and take your application and make it a modern app without hiring additional employees or consultants to actually help you with that, there's a big cost associated with modernizing your applications. So you kind of have to ask yourself if modernizing all of those applications is really worth it. The second bullet here also mentions from ESG research that organizations report needing on average about 27 days to refactor and migrate an application to the cloud. That number actually seems pretty accurate to me, right? I could take an application that was a monolith running on VMs, and we could destructure that application, make it into a distributed monolith or microservices. 27 days, if I've got an engineering team, I can get that done. But there's a lot of other things that have to be done as well when you start modernizing your applications. You're probably going to operationally change the way you're handling those applications, right? Backups and things are different. You know, ticketing systems are different. Maybe we're doing GitOps instead of ITSM or something. You know, there's a lot of different changes that happen when you modernize your apps, other than the coding or the building of the application itself, right? So in this, it says that at this rate, it would take 7.4 years for a business to migrate 100 applications. That's a really long time. So what I'm trying to say is, I think in some cases, you're not going to be modernizing all of your applications. And the last bullet here was only 9% of customers rewrite or refactor when migrating to the cloud. And that's according to IDC. 9%, that's almost nobody, right? That's a very small percentage of the companies that are actually migrating to the cloud. Now, we know that there's tons of enhancements that you get when you modernize your applications, right? You can scale them differently. They can become more resilient. We can have different teams working on the same application at the same time from a code-based standpoint. There's lots of good things. But in some cases, maybe it's not worth actually modernizing your applications because there's just not a business reason to do it. The business needs, you know, a cost justification for why you're modernizing these applications. And some applications run just fine on a virtual machine. There's not a business reason to modernize it. Okay, here's where VMware Cloud on AWS comes into play. So we've still got the VMware Cloud. We've got our VMware vSphere on-premises that we're running, our data center, our private cloud. And with tools like HCX, we can stretch our networks between our on-prem data center and VMware Cloud on AWS. It's pretty simple to do. We can stretch a layer 2 network, and we can do things like vMotion our workloads. No more conversion of our virtual machine to a different instance type of that cloud vendor. You can now actually just take a virtual machine running in vSphere and move it to a different vSphere environment. And you can do it live while it's running. You can also use tools that you're probably already familiar with, like Site Recovery Manager, to migrate your applications at a set time, right? There's a lot of options here, and we really think that you'll be able to move these workloads back and forth as you'd see fit, and we're providing flexibility. But some of your applications, you do want to modernize, right? That's what we're really talking about here. We can use AWS native services, which are connected to VMware Cloud on AWS. VMware Cloud has an elastic network interface that's connected directly into a virtual private cloud. So your VPC has the VMware Cloud on AWS instance running right within it. Kind of similar to an EC2 instance having a NIC on your VPC. It's really the same thing. So now my applications can start changing form. Now, perhaps, I've got an application that started out as a VM or a series of VMs. I can move those to VMware Cloud on AWS, where I get them close to native AWS services that maybe I want to take advantage of for rebuilding my applications in a modern fashion. In this case, I've got kind of a hybrid application. VMware Cloud on AWS is running, in this instance, a Tanzu Kubernetes cluster, right? I've got Kubernetes there. I've got part of my application running in that Kubernetes cluster. I have another part of my application running as VMs in VMware Cloud. But on the other side of the fence, I'm maybe using serverless functions as part of my application, and perhaps my database is actually running in an EC2 instance, or maybe it's a managed service from AWS. My app now kind of spans two clouds, and I get to pick and choose how I'm going to distribute the different parts of that application, right? I pick the best tool for the job in this case, right? And they'll be closely together. No more worrying about bandwidth and latency between your on-premises data center and AWS. So just to kind of tie off on some of the economic value drivers here, VMware Cloud on AWS is the best of both worlds. You get to use the vSphere you're accustomed to from on-prem, but you also get to use AWS native services that you're starting to use, or maybe you've been using as well, in AWS environment, and take advantage of their global footprint. Zero refactoring, so we have lower migration costs here just because it's simple. Your vSphere administrators are probably already capable of handling a vMotion from on-prem to VMware Cloud on AWS. You don't have to go hire consultants. You don't have to retool your existing employees to learn new modern tools. This is a win-win. In cloud economics, it's a lower TCO versus what you're traditionally running on-prem. So we got cloud economics there. Now, I talked a little bit about how we can modernize applications by taking advantage of AWS native services and using some of your capabilities from VMware Cloud on AWS. What I really want to talk about now, and what we're going to talk about the rest of this session, is the new services that got announced this year at VMworld. So if you're a VMware Cloud on AWS customer, you're now also going to get access to Tanzu Services. And Tanzu Services consists of two different products. There's the managed Kubernetes service, so Tanzu Kubernetes Grid as a managed service, and also our multi-cloud Kubernetes management plane, which is a SaaS solution called Tanzu Mission Control. And if you're a VMware Cloud on AWS customer, you're going to get these new capabilities for free. So let's talk a little bit about those two services so we can understand what they are and what they kind of do. The first one is being Tanzu Kubernetes Grid service. It's a managed service. What its job is there to manage the lifecycle of Kubernetes clusters. Got to stamp out lots of Kubernetes clusters? This is the tool to do it. A Tanzu Kubernetes Grid cluster in VMware Cloud on AWS in the managed service is called a supervisor cluster. It's a normal Kubernetes cluster that's got some additional components in it, specifically the cluster API tooling, to deploy additional Tanzu Kubernetes clusters. On top, once we built that supervisor cluster, we'll add a namespace. And a namespace is a way for us to segment network traffic and assign users and resources to them. Once that's done, anyone who has access to that namespace can then spin up additional Kubernetes clusters as long as they're within their resource limits. And that's kind of how this works. And we could have multiple namespaces, and we could have multiple versions of how we've deployed Kubernetes clusters into those namespaces, one to many. There's really three parts to creating one of those namespaces. There's role-based access control. So you're setting up a set of users that are going to have access to use these resources. There's resource allocation. So you've got a finite amount of resources maybe in your SDDC, unless you scale. And you want to make sure that your employees or your development teams or your platform operators, whoever's using the services, are only using the amount of resources that's been assigned to them. And then there's some network segmentation as well. So we've got multiple namespaces. We can make sure that one namespace has no network connectivity to another namespace. So we've got multi-tenancy built in. And here's a little view of that multi-tenancy. This is the VMware Cloud on AWS networking. When you create a new namespace, we spin up a new router, and we connect that router to the existing VMware Cloud on AWS network infrastructure. And then as new Tanzu Kubernetes clusters get built, they get attached to those namespaces. So we can be pretty sure that the networking is not going to, we're not going to have network traffic that is destined from another namespace without us knowing about it. We'll have to open up some firewall rules and things. A quick view of the namespace, and we're going to go through this in the demo itself. But we're in the vSphere interface. This should look familiar to a vSphere administrator. We've got role-based access controls you're going to be configuring here. You're going to be setting up storage. So what data stores am I allowing these users to actually access for our clusters? And then we can also set resource limits to make sure that whoever we assign access to our vSphere environment has as many resources as they've been allocated, right? Maybe a manager has to request a certain number of resources because their team gets billed for that. We don't want to make sure that they're not going over their allocation. In the end, Tanzu Kubernetes Grid in the managed service is really trying to bring together two personas. This is the vSphere administrator or cloud admin, working in vSphere with the tools that they're used to seeing, used to using. And we're also combining it with the platform operator or the SRE or the DevOps administrator, right? And they're going to be using the Kubernetes manifests and YAML things that they've been doing all along with maybe open source Kubernetes, right? We're trying to bring those two together so that they can see and work on the same tool, the same projects using their own tools. The second piece to the Tanzu services that was announced at VMware, at VMworld this year, was Tanzu Mission Control. And Tanzu Mission Control, or TMC, is our multi-cloud Kubernetes control plane. It's a SaaS solution, and it's used to manage our Kubernetes clusters. So Tanzu Mission Control can do things for us like manage the lifecycle and configuration of our Tanzu Kubernetes Grid clusters, right? We don't necessarily need to use Tanzu Kubernetes Grid to deploy our other clusters. Once our supervisor cluster is connected with Tanzu Mission Control, this SaaS solution can be used to deploy additional clusters through API calls or through a GUI for a platform operator, typically. But it also does other things for us. It's showing us some observability metrics, right? We can see CPU and memory and other things. We can see YAML manifests and what is actually running in our Kubernetes cluster. It can provide identity and access management for us into our Kubernetes clusters. And it also does policy management. And I'm going to talk about that here in just a second. When I was a field engineer, a common thing that we saw was every time someone was deploying a new Kubernetes cluster, and many times this was open source Kubernetes, customers were trying it out, and they would be deploying many clusters, and it would not be surprising to see that those clusters had different configurations on them. So in this slide, what you can see is I've got 3 different Kubernetes clusters here. I've got a Tanzu Kubernetes cluster on one side, and I've got 2 other conformant Kubernetes clusters. It doesn't really matter what they are. It could be an Amazon EKS cluster. It could be an OpenShift cluster. It could be any conformant Kubernetes cluster. Tanzu Mission Control can then manage these Kubernetes clusters and make sure that we're distributing a desired state policy for each of these clusters. We no longer have individual clusters we have to configure. We can create a policy for those clusters, and then we can have it applied uniformly across any of the clusters in our groups or our entire fleet if we want to. So now we can make sure that the settings on one cluster should match the settings on another cluster, and we can better manage our Kubernetes environment. A second piece that I kind of like about Tanzu Mission Control that I wanted to demo is the idea of a workspace. So in this case, I've still got those 3 Kubernetes clusters, and in those clusters, I'm sharing them with 2 different teams. So you can see here I've got Team 1 and Team 2, and they both have pods running in those Kubernetes clusters. Now, someone from Team 1 says, hey, I'd like to see a list of all of our resources. I want to see what our resources are doing for just my team across all of those clusters. And Tanzu Mission Control can help us with that. It creates what we call a workspace. And a workspace is just a view of namespaces in your Kubernetes clusters. And you can kind of pick and choose how you want to see these, right? If I wanted to add Team 2 to this, I could add Team 2 to that view as well. But for this example, I'm basically saying I'm only going to show you Team 1's resources across all of those clusters. And Tanzu Mission Control can do that. And we'll show you that in the demo. So this is a typical workflow for an operator using Tanzu services. We have an IT administrator, your vSphere administrator or cloud admin, whatever you want to call them. And what they're going to do is they're going to activate Tanzu Kubernetes Grid. They're going to assign some users to that namespace, and they're going to set resource limits. At that point, what they would do is hand it off to a platform operator or an SRE. The platform operator can then use Tanzu Mission Control to do their deployment of clusters. They can assign policies, they can create workspaces, and then they can work with the development team on what comes next, right? So you may be asking, hey, how can I find some more information out about Tanzu services? There's a VMworld session here listed, MCL 2290. That's done by William Lamb. It does a great job of introducing VMware Cloud on AWS with the new Tanzu services. There's also an announcement blog that you can read there as well. and a technical blog that dives a little bit deeper into like how things work, what's going on under the covers. Last thing I wanted to mention before we get into a demo, I think, is get started with Tanzu Kubernetes Grid. If you want to get started right now, VMware announced a Tanzu Community Edition this year at VMworld. So you can actually go out, download the VMware Tanzu Community Edition, and start installing your own Kubernetes clusters for free. And highly recommend you do this. Really cool tool, really excited about this announcement. And with that, let's switch over and get into a demo.
First thing we're going to do in our demo is we're going to take over the persona of the IT admin or the cloud admin or the vSphere admin. Their job is going to be to activate the Tanzu Kubernetes Grid service, and then assign users and groups, and then set resource limits. And we're going to do this through a namespace. So we'll do this first in our demo. Okay, so here I am in our demo environment. And I've pulled up one of our SDDCs from VMware Cloud on AWS. And you can see here in the front screen that we've got Tanzu Kubernetes Grid, and it shows a status of deactivated. To activate the Tanzu Kubernetes Grid managed service, all we need to do is go to the Actions dropdown and click the Activate Tanzu Kubernetes Grid button. We do a resource check here to make sure that clusters that are in that SDDC have enough resources to actually deploy the supervisor cluster. And then next, you'll be presented with a screen that is asking you for information about the networking that's going to be deployed in the VMware Cloud on AWS environment. So we filled in a service CIDR that typically can stay the same. Namespace, ingress, and egress CIDRs are often changed depending on the customer requirements. So for this, I'm going to be entering in 3 different CIDR addresses. These are pools of addresses that are going to be used to stand up new networks and NATing for ingress and egress. And there's a helpful video here on the screen that will actually explain how the networking works and how everything's laid out. So if you're having questions about how those things work, you can click on that video. But for now, we'll just go ahead and put in the namespace information and an ingress CIDR. This will handle all the traffic coming into our cluster. And then an egress CIDR, which is a single point where all of our traffic will exit our cluster. And then we can click the validate and proceed. And validate and proceed is going to make sure that you don't have an overlapping CIDR address with any of the VMware Cloud on AWS networks that maybe you've already deployed. It can't check to see if you have CIDR addresses that you maybe are overlapping with something you have on-prem. That's going to be up to you, but this does a quick check just to make sure you don't have anything in VMware Cloud on AWS that's got an overlapping CIDR address. And that's really it. There's only a couple stages here to setting this up. You click activate the Tanzu Kubernetes Grid, and then it starts the activation process here. You'll see a few messages pop up saying that this is in progress, and eventually this will say that it's activated. This process takes a little bit of time, so I'm switching over to another organization where this activation is already completed. The activation typically takes about 20 minutes for the supervisor cluster to come up. So here I am in my other organization where I have already completed the activation. You can see here on the first screen we have Tanzu Kubernetes Grid, shows activated. And now under actions we see that we can deactivate Tanzu Kubernetes Grid if we needed to later on. Okay, so next thing, let's take a look at what we see now in vCenter. Here's the vSphere client. We can see we've got our cluster with ESXi hosts in it. We've got our resource pools. And now under the management resource pool, you'll notice we have 3 VMs called supervisor control plane VMs. These are the control plane for Tanzu Kubernetes Grid service. If we look under namespaces, I have one already built named Hardtop. It's for a fictional company called Hardtop Hotels that we use for demos and things. But typically there's no namespaces here, and your next step would be to go and create a namespace, which is what we're going to do now. So in the dropdown, we can go to workload management. You can also see that in workload management, we've got a supervisor cluster and it's got a status here running. There's 3 hosts in it, meaning we've got 3 ESXi hosts. And there's one namespace here already. This is one I'm using for a later part of the demo, but let's create a new namespace. Now, a namespace is there to help segment traffic, so we can isolate clusters from each other at a networking perspective, but also for resources and access. So let's give this a name. Let's just call it my demo, and we'll click create, and that's it. Our next step is we've got this namespace. We're going to first assign some permissions to it. So we'll click on add permissions. And I'll just add my own user account. I'm currently logged into the vCenter vSphere client as the cloud admin account, and I'm adding my own account now as a user. And I've got edit permissions, edit meaning I have the ability to go and create new clusters. Whereas if you use view, view allows you to actually just view the resources. Okay, now that I've assigned some permissions to this namespace, what I also have to do is assign some resources. The next step of the process would be to add some storage. If I click add storage, I'm being presented with a list of storage policies. And in VMware vSphere, we use storage policies to identify what type of disks go on what type of data stores. And in this case, we have to do the same thing, right? When we deploy new Kubernetes clusters, we need to know the virtual machines that are going to host those nodes, where their disks are going to live, and we're going to put those on one of these data stores. That's defined by the policies here. Or if we have pods that need persistent data, they've got persistent volumes, they're going to issue a persistent volume claim, and those claims are going to apply to a storage policy. That storage policy is going to be associated with a Kubernetes storage class, and that's how they're going to be given disk for pods that are running in the Kubernetes cluster. So this defines kind of a lot of things. Next, now that we've done storage, we can set limits on CPU and memory. Now, if you're a vSphere administrator, this is very similar to like a resource pool limit or like a vApp limit or a virtual machine limit. You can set CPU, memory, and you can also set storage. And you can also set it, if you specified multiple storage policies, you can set a limit on the amount of disk you're allowed to use as well for each one of those storage policies. So for here, I'll just say that we've got a limit of 500 gigs. And that means that my user, which has been assigned access, can deploy Kubernetes clusters on data stores defined by this storage policy. In this case, they're going to be deployed on vSAN. And then in the limits, I've got a 500 gig memory limit. That's how I'll be able to go out and provision my own clusters as long as I stay within those parameters. Okay, back to our mall map here where we're at. We just finished in our demo the persona of the IT admin, where we activated the TKG service, we assigned users and groups, and we set resource limits on our namespace. What we're going to do for the second part of the demo is take over the platform operator, or SRE persona, to deploy clusters, assign policies, and create workspaces. And we'll do all of this through Tanzu Mission Control. As a platform operator, we got to go over to Tanzu Mission Control. So we'll go back to the Cloud Services portal and get to Tanzu Mission Control. We're now in Tanzu Mission Control, and the first thing I want to show you is how TMC is connected with our supervisor cluster so that we can perform operations. Here you can see we've got our Tanzu Services supervisor cluster registered as a management cluster in Tanzu Mission Control. What this means is Tanzu Mission Control can now use this supervisor cluster to do deployments of additional workload clusters. We look in here, we can see that I've got a couple of provisioners. The provisioners equate to a namespace. So we created namespace my demo just a few minutes ago. My demo is now listed as a provisioner in our Tanzu Mission Control without us making any changes. It just knows that there's a new provisioner. And if we look in workload clusters, you can see I have several workload clusters, and you can tell which provisioner they're deployed to. So they're all in that hard top namespace. We're going to deploy a cluster into our MyDemo namespace. So to do that, let's go back to clusters. And this time we'll click the Create Cluster button. First thing we have to do is select which one of our management clusters we're going to be deploying from. I'm going to choose Tanzu Services. Next, we'll have to add what the provisioner is. And in this case, we're going to select MyDemo. We'll give the cluster a name, and we'll call it Demo Cluster 1. And then we can select a cluster group. I'm going to leave this at default, but a cluster group is just a grouping of Kubernetes clusters so that we can do fun things like assign policies to them, right? Think, for example, maybe you want a certain security policy on your production clusters, but maybe not the same not the same security policy on a lab environment or a dev environment or something like that. You can group those clusters however you need to. Maybe you're grouping them by team. But then you assign those clusters to a group, you can assign policies to them. We can add labels and descriptions. But then the next thing, we need to select the version. Now there's a few versions that'll be available to you. Pick which version you want. And then you'll have to enter in some pod CIDR and a service CIDR for your Kubernetes clusters. If you want to accept the defaults, that should be okay. We also have the option to set proxies. So if you need to set a proxy to get access to a certain area of your network or the internet or something like that, you can set up a proxy so that your Kubernetes clusters get deployed with those proxy settings configured already in them. Then next is persistent volume storage. So we're going to select Tanzu storage. Remember the storage classes or the storage policy that we assigned when we activated our namespace? Well, that's going to show up here. We can select which one we're going to use for persistent volume storage for our pods. On the next screen, we have to set whether or not we have a single node for the cluster or it's highly available. So single node means a single control plane node, and you can have multiple workers, versus highly available, which means you're going to have 3 control plane nodes and as many workers as you can fit. You'll also have to select a size. So there's best effort types and guaranteed types. Best effort meaning whether or not they're reserving resources in your vSphere cluster or if they're sharing. I'm going to choose best effort medium. And this is for my control plane. Now on the next screen, we're going to do the node pool. And the node pool is a list of workers. So right now we only have one node pool, but you can imagine creating additional node pools and maybe using those node pools as for different operations. Maybe some of them have GPUs and some of them don't or something. You can imagine that happening. So here we're going to do the same thing. We're going to set the worker size. We can set a storage class, and then we can set the number of worker nodes that are going to be deployed. So I'm going to choose 3. So with 3 control plane nodes for a highly available cluster and 3 worker nodes, we should have 6 when we're all done. Now we'll go through the cluster creation process. While we're waiting, let's go see what we can do with some of the other things in Tanzu Mission Control. So you can see my cluster groups. I have the default one, which we use for our MyDemo cluster. I've also got a development and a production group. Now, in a similar way that we create cluster groups for clusters, we do a similar thing for namespaces. So if we look in our namespaces here, you can see a whole list of namespaces for clusters that are already registered with Tanzu Mission Control. What we can do is we can create a workspace, which is essentially a group of namespaces, and it doesn't matter what cluster they're on. So you can see here I've got a namespace called Loyalty. If I go into Loyalty, I've got namespaces named Loyalty across my Dev, Prod, and QA cluster, and a namespace called Web across the same 3 clusters. And then what I can do is I can look at the workloads. and I can see a consolidated list of the workloads in one place. Multiple clusters, one namespace, two namespaces, however many need to group together. And you can see those all in one place. And then you can get additional data. Like I obviously have some unhealthy pods in production. Probably a bad thing. If we click into those, we can get information about, if it's a set of pods, we've got a deployment. We can see the YAML manifest that actually is running this configuration, so we could copy this and use it someplace else if we wanted to. We got CPU and memory information all in one place, and then you can assign these to users. Next up is something that doesn't come with the Tanzu Services core license. But as you upgrade to a standard license, you'll have policy management. And for policy management, we can add things like access policies for who has access to the clusters. We can set image registry policies for which registries we're going to allow Kubernetes to pull containers from. We can set network policies for segmentation. We can set security policies for container escapes and what access those containers have to operating systems. Quota policies for namespaces. And if you get to the advanced licensing, you can do custom policies where you can write anything you want. For this demo, we're going to do an image registry policy just to show how that works. An image registry policy prevents a certain namespace from being able to download a Kubernetes container image from a container registry. So what I did here is we look under workspaces and that loyalty workspace. You can see I've got a harbor only image policy. Let's look at it. Other rule. We've got a rule here named harbor.hardtophotels.com, and that's the host name. And that's the only thing in this rule. So setting this means that the only image registry that we'll be allowed to pull from is our harbor.hardtophotels.com image registry. If it's Docker Hub or something else, it's not going to be allowed. This allows our developers to have a more secure environment to store their images because then they know everything that's in them. Common rule. Let's test that out and see what we would see if we were in the command line for a Kubernetes cluster. So I've opened Visual Studio so we can test this out. And the first thing I want to do is show my context. So let's do kubectl config current context. And you can see I'm in my htdev context, which means I'm connected to my htdev cluster. That's one of the clusters that's associated with those image policies from Tanzu Mission Control. So if that's true, I shouldn't be able to deploy an image from, say, Docker Hub. So just as an example, let's try that out. Let's do kubectl run, and we'll call this nginx image equals nginx, and the namespace is loyalty. So since I didn't specify my image registry, it should be pulling from Docker Hub. And I get an error. And the error gives me a really helpful information about why I got an error. And it says right here that the host name is not harbor.hardtophotels.com. So that's pretty neat. Now, let's try this again, but let's not use the loyalty namespace. Let's just deploy it to the default namespace. And then it works just fine. So our policy is associated with the namespace that we associated it with. Perfect, the way we wanted it. Let's also deploy our YAML manifest that actually from the harbor.hardtophotels.com image registry. And this YAML manifest is deploying a deployment. It's also got a service in here of type load balancer. So what this is going to do is create a new service. That service is going to be picked up by the internals of the Kubernetes cluster, and we're going to create an NSX load balancer to direct the traffic into this cluster. So we'll see that. Let's just do a kubectl apply on that file. And it looks like everything created okay. And now let's go ahead and take a look at our pods. On the loyalty namespace. And you can see there's still one of them still starting up here. But things look good. Let's check out our services. And there you can see I've got this loyalty service, and it's got an external IP. This is the virtual IP address that's assigned to our NSX load balancer. So if I pull this up in a web browser, you can see that our application is up and running. Everything looks good. And that brings us to the conclusion of our demo. Hopefully with the lecture and the demo, you've learned something new about Tanzu services and you can see how they're working. And I look forward to talking to you again in the future. Thanks for your time.